Seventh grade, we're in week 14, and we're still talking about plate tectonics. We're going to talk about the theory of plate tectonics. Like any great theory, plate tectonics makes a tremendous amount of sense. The whole story fits together so perfectly. Wegener had so much evidence that the continents had once been joined. Seafloor spreading is a perfect mechanism for moving these continents. It's really too bad that Alfred Wegener was not here to learn about the theory of plate tectonics. It seems certain that he would have been ecstatic. The theory of plate tectonics is what brings together continental drift and seafloor spreading. Plates are made of lithosphere, topped with oceanic and/or continental crust. The plates are moved around the Earth's surface by seafloor spreading. Convection in the mantle drives seafloor spreading. Oceanic crust is created by mid-ocean ridges. The crust moves outward from the ridge over time. The crust may eventually sink into the mantle or be destroyed. If a continent sits on a plate with a mid-ocean ridge, the continent will be pushed along. There are different types of plate boundaries. When two plates meet, this is known as a plate boundary. There are three types of plate boundaries since there are three ways in which plates can meet. Plates can move away from each other, they can move toward each other, and finally they can slide past each other. The three different types of plate boundaries are divergent, moving away from each other, convergent, moving towards each other, and transform, moving alongside of each other. They are described in the following three concepts. Most geological activity takes place on plate boundaries. This activity includes volcanoes, earthquakes, and mountain building. The activity occurs as plates interact. Giant slabs of lithosphere move around and can create a lot of activity. These features seen on a plate boundary are determined by the direction of the plate motion and by the type of crust found at the boundary. The theory of plate tectonics explains most of the features of Earth's surface. It explains why earthquakes, volcanoes, and mountain ranges are where they are. It explains where to find some mineral resources. Plate tectonics is the key that unlocks many of the mysteries of our amazing planet. Plate tectonics theory explains why Earth's geography has changed over time and continues to change today. Some places are prone to earthquakes while others are not. Certain regions may have deadly, mild, or no volcanic eruptions at all. Mountain ranges are located where they are. It explains many ore deposits and why they are located where they are. Living and fossil species of plants and animals, where they are found where they are. And some continental margins have a lot of geological activity, and some have none. Altogether, plate tectonic motions affect Earth's rock cycle, the climate, and even the evolution of life. In summary, the theory of plate tectonics brings together continental drift and seafloor spreading. At a plate boundary, two plates can be moving apart, together or past each other. Plate tectonics theory explains many things in geology, such as where volcanoes, earthquakes, mountain ranges, ore deposits, and other features are located. So by now you should be able to demonstrate your knowledge of what the theory of plate tectonics explains. What are the things that we now understand better because of the theory of plate tectonics? If you can do that, move on to the next activities. Otherwise, go ahead and go back and view the video one more time.